Yeah, I guess for the sake of time, we're ready to kick it off. In today's session, we will go over the Portworx solution and how to handle persistent storage and disaster recovery in the Kubernetes environment. So my name is Anders Johnson. I represent Conscia, and I'm a sales specialist here for our automation and cloud infrastructure department. With me I have Christian. Maybe a couple brief words from you, who you are and so on.
Yes, so good morning everyone. So I'm Christian Stan. I'm cloud native architect, part of the Portworx team, working together with our partners in order to, let's say, deliver we call it the best solution right now for the enterprise environments in Kubernetes when we are talking about data availability. And I'm happy to be here.
Great, thank you. So today's agenda, if I can get, here we go. Yeah, the introduction is already taken care of. That's great. Some groundkeeping rules. We have a chat here, so if you want to post questions throughout the call, please do so, and we will try to deal with them along the presentation here. At the end of the session, there's always, the classical evaluation form that you can fill out. We also added a question there that if you would be interested after this session to perhaps do a hands-on lab on Portworx, it's just a yes and no question. Fill that out, and if you're interested to do so, we will make sure to set something up for you or find one of the scheduled sessions that is already planned for this. So keep that in mind. So let's kick it off with a reference case here from Sweden. And then Christian will take over and go over, give you the overview of what Portworx is, it does, and why Portworx might be a good fit for you and how it can be applied. And at the end, we also finish off with a Q&A session if anyone has something you would like to discuss and get some answers around as well. So let's kick it off. So the background. The customer in Sweden, Saint-Gobain Distribution Sweden AB, or SGDS in short. It's part of the large French industrial group Saint-Gobain, as you can tell from the name. In Sweden, they are known for, they have a large operation in construction and installation where they provide products and services under a number of different brands, as you can see here on the slide. It consists of a number of retail chains, nearly 180 locations and approximately around 3,000 employees. I mean, retail drives quite a lot of number in terms of employees. So SGDS is really a business support organization for this group, and they provide a number of different services such as finance, HR, logistics, and in this case, IT services for the group. So when we got in contact with them, a little bit of case background, if you will, they were looking to implement a new and modern integrations platform based on IBM Cloud, the IBM Cloud Pak offering. Essentially, for you who are not familiar with that, it's a quite rich set of rich platform set of a number of services in terms of API integration, application integration, business process automation, a number of different services for companies in various industries looking to enhance and modernize and do a, should I say, digital transformation journey, if you will. This was installed on an OpenShift container platform, and they were at the moment using Trident by NetApp for their persistent storage, but that was not part of the support matrix from IBM Cloud Paks. So they had to evaluate some other options in order to have a stable and secure environment, because this was, you know, customer facing, business critical applications that was using this platform. And they nailed it down to a number of different options. Red Hat OpenShift Data Foundation, or ODF for short, Portworx Enterprise, and IBM Spectrum were the ones standing out in the support matrix. They quite quickly moved on from and left IBM Spectrum, because before they implemented the Trident solution, they actually used IBM Spectrum, and due to some support complexity and so on that they experienced in the past, they decided to proceed with Portworx and Red Hat in a POC stage, if you will. In conclusion then, what made them select Portworx? First and foremost, it was after 2 thorough POCs and TCO calculations and all of the due diligence you really need to do when evaluating something like this. It came down to simplicity, deployment, and management. That was the number one and key reason. They also found this more cost effective, and it met all the requirements, criteria in terms of functionality and so on that they set out before they started this project. And I would say what really tipped the scale when we spoke to them was the kind of commitment and support they experienced from Conscia and nonetheless, especially the Portworx team when evaluating this. I mean, this was a project discussion and POC that actually, we spent more or less 18 months from the first discussion until the POC was completed and done. So it was a quite long journey, but they really felt comfortable that they made the right decision after taking these steps with us. So now I'm handing over to you, Christian, to explain a little bit more around why some of these topics that they found important may actually be applicable to you who's joining this call today as well.
Thank you.
Oh, maybe I need to allow access for you again. Yeah, sorry.
Thank you so much. Okay, so let's see if it's working.
Okay, good. Thanks.
So thank you for the introduction. Actually, it's one of the, let's say, typical use cases that we are seeing across the, I would say, across the region. And yes, our collaboration with usually with OpenShift was a very good one. Actually, I would say Red Hat being one of the promoters of going through solutions like Portworx, because they know they can ensure the availability and the performance. But what is Portworx actually? So we are calling it a data availability platform for Kubernetes. And what does that mean? Meaning that, well, besides the persistent storage part, we can do more than that. We can do, as I mentioned, data availability. We can do disaster recovery. We can do resiliency. We can do high availability at the cluster level. We can do security. We can implement some automated features inside your, let's say, your Kubernetes clusters related to data, and not only. Of course, we can do backup, and you'll see we are like very agnostic from the platform perspective, and also from the, let's call it from the hardware perspective. So the idea with, let's say, this buzzword, which is called application modernization, actually, it's related to the trend of application moving to containers. So more and more customers are looking at their applications, and I'm not referring here only to the existing one, but new applications. Usually most of them are built in a cloud native concept, meaning that most of them right now are built for containers, so they will need to run in a containerized environment. But they will need to have an orchestrator for that. And since like couple, I don't know, 5-10 years ago, when the concept of containerized environment was, let's say, launched on the market, the idea was that a container is something ephemeral, right? But right now we are talking about persistency and stateful application running on containers, which induce a little bit of complexity when it comes to, let's say, how we are going to do the data persistent, even from the business perspective. So basically, from the business perspective, how can you do the data availability? Now, it is a study which says that 30% of the enterprise application will run in containers at some point till 2029. I will say it's going to be more than that. I'm looking what is happening on the market, and more applications are being, as I said, launched for containers. And even if I'm looking what's happening right now in database, let's say, landscape, I think except a couple of very old databases which are not migrated to containers, the majority of the enterprise-grade databases running right now can be moved to containers. Another topic which is pretty hot these days, it's related to an alternative to VMware. So basically, more and more people are looking for alternatives to substitute part of the Broadcom licenses because of, let's say, Broadcom strategy, because of the costs, because at some point they will want something which is more slim from the deployment perspective, from the cost perspective. And right now, there is possibility to run Kubernetes and virtual machines on the same platforms. There are a couple of vendors which are offering this solution at a very good price with very good features. And together with Portworx, actually, you can get the same functionalities as you can have in VMware. And because, for example, artificial intelligence and machine learning are two hot topics right now, most of the applications which are being developed for machine learning, or I think more than 80% of the AI engines which are being run right now in the market are based on containers. So there is plenty of persistent data right now, which is being, let's say, converted from, let's say, the traditional approach to the containerized approach. Now, Kubernetes, yeah, it's complex. Actually, I was reading a study a couple of days ago. The 4 main topics when it comes to Kubernetes, which raise a couple of concerns from the customer side, are the learning curve. So basically, it seems that the learning curve, it's something that it's a huge concern, because people will need to reconvert at some point to learn and to know how to work with Kubernetes. The second one was resource consumption and resource monetization. The third one was networking and security. And the fourth one was data availability. So a lot of people migrating to containerized platforms are looking at these 4 topics. Actually, with Portworx, we can solve probably more than half of these issues, because we know how to do data availability, we know how to optimize the resource consumption. We are offering very good monitoring part, and more than that, we developed the product in order to be very easy to use. So this is something which is very important for a customer which is looking to a solution at an enterprise grade. So actually, the problem with data in Kubernetes, it's related to the scale. So when you try to scale at some point, of course, you are going to reach some limitation depending on what you are using. So you just heard the example presented like a couple of minutes ago, that the customer started with a traditional CSI approach, and then they were somehow forced to move to another solution which was a more enterprise grade. And why is that happening? Because actually, at some point when you are starting the journey with Kubernetes, maybe a traditional CSI driver can do the job, but at some point you are going to reach the limitation. And more than that, Kubernetes was designed to be agnostic. So the idea of Kubernetes was to be totally agnostic. So basically, I don't care about the hardware. Why should I care about the fact that I should stay tied to a vendor, for example, like NetApp, and not being able to do this some kind of abstractization and being able to use not only NetApp, but if I want to use NetApp, if I want to use Dell, if I want to use, I don't know, HP, Pure, Hitachi, whatever, in the same cluster and having the same functionality from day zero up to the let's say up to the production. So being complex, data management, it's complex in Kubernetes. Because we all usually we are all starting from a traditional approach where data is being kept in silos, where in terms of resiliency, we tend to do the resiliency still based on hardware, which it's not the case in Kubernetes. If you are looking actually what the design of the Kubernetes platform is presented right now by the big cloud vendors. Actually, you can see that everything is decoupled. Everything should be flexible and should be no dependencies between the let's say the environment itself and the hardware which is serving that. Data security is very important. A lot of customers which are migrating applications to Kubernetes, which are using persistent data in Kubernetes, are checking the data security. Why? Because it's the same concept like in a traditional world, like in VMware, or like in bare metal. Actually, I need to control how I'm doing the access to my data. I need to be prepared, for example, even for a ransomware attack. And just to give you an idea, right now in a Kubernetes world, we have 7 major surface for attack in a ransomware situation. So there is plenty of resources to be exploited. And of course, we are also talking about developer experience. So developers usually, they should not care about actually what is happening inside the platform. They just want to consume the resources, and they want to do it in a very automatic way, right? So they don't want to do anything manual. So actually, what is the desired state is to have like a unified data management, to be able to build solutions which are capable of doing disaster recovery, data availability, right? Zero data loss, which is important because if I'm moving a critical database to Kubernetes, I need to be sure I'm not going to lose or corrupt data. I need to improve the security. So basically, I will need to control the access to the data. I will need to be able to encrypt the data granularly. So by the way, encrypting the storage, it's not going to solve the Kubernetes problem. So in Kubernetes, even if I'm encrypting the physical storage, I can mount a volume like in minutes if I know how to do it. And of course, I want to have something which is pretty much automated. So I don't want to do manual failovers. I don't want to do volume bound and all these operations, which requires time. And at some point, it's consuming additional resources. So actually, what is Portworx? As I mentioned, it's a data availability for Kubernetes environment. What we can do, we can unify, let's say, the consumption model. So we are being agnostic. You can run Portworx in almost all the distributions right now. You can run Portworx in probably right now like 12 or 14 platforms. From OpenShift, Rancher, Mirantis, Kubernetes, we are supporting a lot of platforms. You can run it on-prem, on the cloud. You can consume for example, Portworx's subscription in Azure or AWS at some point. You can create hybrid environments like creating data mobility between on-prem to the cloud. We can protect the data. we know how to do the data availability, we know how to encrypt the data, we know how to do role-based access control, and of course, we know how to do the automation part. So basically, we can run anywhere, run on top of anything, almost anything. We can be agnostic to the hardware part, and we can offer the application like a comfort zone in order to be sure that I'm not going to lose data, I do have availability, and I also have security. Now, if you are looking at the business outcome, actually, yes, because in this industry, we are also talking about money. As you probably know or already hit the issue, meaning that if it's free, it doesn't mean it's costless because, well, usually sometimes cheap solutions don't solve the big picture, and we ended up investing like personnel resources in order to solve a problem which it's already present on the market. So actually with Portworx, we are talking about day zero operations, which can, with Portworx deployment, it's happening in a couple of minutes. Starting from that moment, we can build a disaster recovery scenarios if needed. For environments running a mixture of VMs and containers, we can do both, and we can reduce the Broadcom overhead. And of course, because of the automated parts which are included, we can also do the OpEx saving. Now, if you are looking at the list of the customers, and this is not the whole list, by the way, these are just a couple of customers using Portworx. We are talking about, I don't know, about governmental institutions, finance, insurance, manufacturing, I don't know, transportation, a lot of companies which are right now using Portworx. And some of them, of course, even military, we have huge military customers using Portworx in production in real, I would say, environments which are like heavy stressed. Now, because well, some of the people are also looking at what the IDC it's saying. I think we have a very good position right now related to the other vendors in the industry. And I think if you are looking at the whole picture of the whole Portworx functionality, what we can deliver, I think we are like pretty much unique related to the functionalities that we can offer with a single platform. I don't know if you know, but GigaOM, it's something which is pretty similar to Gartner for other industries. And GigaOM is positioning Portworx as one of the innovators and one of the leaders in the industry when we are talking about data availability in Kubernetes. And we are there for more than 5 years. So the fact that, for example, as I told you, Red Hat or SUSE is promoting us as a trustful and reliable vendor for their environment, I would say it says a lot. Now, let's take a look of actually what is happening inside Portworx and actually how we are, let's say, doing all these functionalities somehow based on the feature level. So, just a short, let's say, introduction. Well, when we are talking about containers, actually related to VMware, it's or to virtualized environments, it's a little bit different, right? So, when talking about containers, actually doing the persistent data relies on a standard, which is the CSI standard, right? Based on the CSI standard, you can provide persistent storage to the to Kubernetes environment. Now, since the CSI standard, I would say it's related to the vendor which is building the hardware solution. So every vendor, and not only the hardware, for example, if you're using VMware, probably at some point you're going to use the VMware, the vSphere CSI. But based on that, on the CSI capabilities, we are building the storage classes. And storage classes can have different parameters depending on the CSI capabilities. Now, not all the vendors are able to provide the same capabilities. Not all the vendors are able to provide, let's say, a roadmap for their CSI. And as you've seen in the introduction, actually at some point, some vendors get discontinued because they're not supported by the big platforms. So actually what Portworx does is doing like an abstractization layer. So we are moving from the connector approach of having a traditional CSI driver in the environment to a more native storage approach in a containerized world where we can run on top of any physical device, any physical solution, and we can provide a unified, let's say, solution to the cluster. So basically, we are getting rid of that one-to-one mapping. We can, let's say, even at some point, we can work with multiple physical providers. So basically, in your cluster can have, I don't know, 1, 2, 3, 4 storage providers. You can have local drives. You can have cloud drives, which is the concept of using, for example, VMware, VMFS as a provider. And you can do an abstractization on top of all of that, creating our own storage pools. Of course, it's CSI based because there is no other way to provide a persistent storage to Kubernetes. But we know how to do other things, and you are going to have the same functionalities across the whole environment. So basically, it doesn't matter again if we are running on local drives. It can be a mix. For example, nodes running local drives, some nodes being connected to the physical storage, and some nodes having not a single block device attached. We can do an abstractization at the cluster level, and all the data availability can be done based on Portworx functionalities. Now, this means that we know how to do the snapshot parting, the encryption. We know how to do we know how to do the DR part, business continuity. We have concepts like multi-zone availability, which is very important when you want to deploy a cluster and have the zone availability. We know how to migrate from one cluster to another, the whole application, and not only the data. We are very easy to scale up and down, and we can easily migrate from one cluster to another, from one platform to another, from on-prem to the cloud, or from cloud to the on-prem. That's very easy to achieve with Portworx. And of course, for example, we know how to work with features in order to automate a node failover, a volume increase, a storage pool increase, a cluster scale at some point up to thousands of nodes. And all of these functionalities comes in the Portworx platform. So as I mentioned, we can run on any Kubernetes distribution. I would say, let's say, most of the Kubernetes distributions. We can integrate with most of the platforms which are available right now in the industry. And actually, from the application perspective, it's very agnostic. Now, if you are looking at the components itself, actually, we are talking about a couple of components which are part of the Portworx suite. And I will start with pxStore. So pxStore is the, let's say, that abstractization layer which we are deploying on the Kubernetes. By the way, Portworx is being deployed as, let's say, a Kubernetes application, a containerized application. So we are deploying our components on worker nodes in a dedicated namespace for Portworx. We are operator-based, so the operator is doing all the lifecycle management part, and we can run on the whole cluster, or we can run on a couple of nodes in the cluster, depending if the customer decides to go for the Portworx services for the whole cluster, or just a couple of nodes in the cluster. Now, After providing the persistent storage part and providing the availability together with PX Store, we know how to do migration. So PX Migrate gives you the possibility to move an application from one cluster to another, as I told you, from the on-prem to the cloud. And here again, I'm not talking about only the data. I'm also talking about the application itself, all the objects which are being encapsulated inside of a namespace. Deployment, stateful sets, I don't know, config maps, secrets, custom resources, it doesn't matter. PX Secure gives you the possibility to ensure security at the cluster level. So basically, if we are talking about, I don't know, role-based authentication, or if we are talking about encrypting the volumes with different keys at some point. So we do support Kubernetes secrets, and we also support external key providers. And on top of that, together with Autopilot, which is a very nice component, Autopilot can monitor your applications in the cluster. And based on some conditions, let's say, I don't know, you have an application which at some point you'll know is going to reach a certain amount of data, but you don't want to fully allocate the data from day one. So basically, instead of allocating 2 tera, you are going to say, okay, I'm going to create a volume with 500 gigs. I'm going to activate Autopilot, and I'm going to say, the moment that you're going to reach 60% occupancy on the volume, please increase my volume with, I don't know, another 20% or another 200 gigs and do this operation until you are going to reach 2 terabytes. So this is working on-prem and on the cloud. It's very appreciated because, well, you have a control mechanism not to waste at some point the resources in the cluster. All these 4 components are part of the PX Enterprise. So, and on top of the enterprise, we can run the DR. So Portworx DR is that functionality that gives you the possibility to have disaster recovery from one cluster to another, asynchronous or synchronous. So we are talking about asynchronous 1 minute RPO, or synchronous, which is 0 minutes RPO, meaning that I can have like a full sync between 2 Kubernetes clusters. And the last component, which is the PX backup, can run independently. So it doesn't require to have enterprise as a backend, but at some point it's desirable because there are some integrations between backup and enterprise. With backup, we can do backup for applications running on Kubernetes. And since I think beginning of this year, we are also supporting doing backup for VMs which are running on KubeVirt. So if you are deploying a cluster, OpenShift cluster supporting OpenShift virtualization, or SUSE Rancher with Harvester, we know how to do also VM backup at some point. These are the components which we do run right now in Portworx as a platform. Now, day 0 operation, we are talking about deploying the Portworx and being able to have, like in half an hour, a fully functional solution where I have the storage pool created, I have the storage class configured, and I can start deploying my applications using the storage class definitions that I already created. Or I can create new storage classes based on my requirements. Storage class parameters are quite, I would say, a huge number of them. So basically, we even can do, for example, scheduled snapshots inside the storage class definition. So basically, you can do like a scheduled snapshot of the data, and you can also, for example, export that snapshot to an S3 target at some point. And this is part of the storage class definition. If we are talking about data operations, it's about how I'm going to handle my data. So we are talking about autopilot, for example, or intelligent volume placement, like I want my volumes to be placed based on, I don't know, volume placement strategies in Kubernetes. I can build multi-availability zones. I can build, I don't know, rack distributions. I can build region distribution at some point. And we know also how to do, for example, application I/O control. So if I want to be sure, for example, an application is not having issues with noisy neighbors, we can do that from tuning the, let's say, the data plane. Upgrade and lifecycle management is pretty easy. Everything is fully automated. It's done one node at a time if needed. If it's need for more, we can increase it. And everything should happen automatically. Usually we are supporting N-3, N+3 platform versions or Kubernetes distributions. So actually upgrading your Kubernetes distribution doesn't mean that the Portworx is not going to support it. So it doesn't have to be like a forced upgrade for everything. And that's important, for example, for customer using platforms like OpenShift or SUSE, because they know that they can do the platform upgrade without impacting their data. Now, backup, it's important because a lot of customers I'm seeing, they're trying to build their own solution for backup at some point, which is a lot of scripting, a lot of, let's say, data movement, manually data movement. With Portworx, it's pretty simple. You just need to have the backup component running and an S3 or NFS target, and we can do the backup. Backup is very granular, so I can drill down up to the objects in a Kubernetes cluster. I can select which objects I want to backup. I can restore on another cluster. I can restore on a cloud platform. I can, I don't know, take backup in the cloud and restore it on my on-prem environment. Even if I'm losing the backup, let's say, instance for good, I'm just installing a new one, go for the S3 bucket, configured with the previous backups, scan it, and then there it is. I can import my backups and I can restore them anywhere. Now, disaster recovery is, I would say, pretty important as a component. And it's important because disaster recovery in Kubernetes, actually it's related to the, I would say it's related to the application itself. So we are not talking about, I don't know, restarting a worker node which is running in VMware or another VMware cluster, or I don't know, on another node in VMware, because, well, that's not disaster recovery for Kubernetes. For Kubernetes, the disaster recovery must happen at the application level. So this means I can do a granular selection of my application components. So I can either do a disaster recovery for the whole namespace, or I can do a disaster recovery for certain components inside my namespace, or I can do disaster recovery only for the data, and I'm going to redeploy the rest of the components on the secondary cluster. That's up to the customer to decide. We can do up to 1 minute RPO right now with asynchronous, and with 0 RPO for synchronous replication. Synchronous replication has 2 caveats. You will need to have 10 milliseconds round trip between the 2 locations, so between the 2 clusters, and it will require to run the KVDB or the etcd database outside of those 2 clusters, because, well, if it's running inside of one of the clusters and you are losing the cluster, actually you are losing the, let's say, the cluster consistency. Security and compliance. So we are talking about doing the granular access control, so role-based access control. We are talking about volume or cluster encryption. So encryption can be activated at the cluster level or can be activated at the volume level. We have the industry standard compliance certification. So even for backup right now, we can do immutable backups, right? So if the S3 component knows how to work with object log, we can also enable it, and we can do the security even for the backup part. Now, data agility anywhere it's related to the fact that we are not tied to any platform. So basically, you can have multiple platforms, and by the way, you can manage them at some point, let's say, from the same place. The idea is that you are not tied to a certain platform when using Porter. So basically, you can have, I don't know, an on-prem cluster running OpenShift, right? And you can have like a disaster recovery in the cloud on Azure or AWS. And we know how to do, for example, data migration. We know how to do disaster recovery between those two components, which is very important, because at some point when you want to migrate data from one platform to another, well, you either do a backup and restore and take some time, if the backup is successful, or you'll need to do some scripting at some point. With Porters, it's native. Now, if we are looking at the ecosystem of partners, as I told you, we are agnostic. So basically, we have a lot of partners which we are working with, from Red Hat, OpenShift as a platform, SUSE with Rancher Prime and Harvester right now for virtual machines. We started a very nice collaboration with Kubernetes. Spectro Cloud, again, it's something that we start working, I think, last year, and we announced our collaboration. So basically, from the distribution perspective, we can run on almost all the distributions in the market. I'm saying almost because there are some specific distributions which let's say they do not permit running some modules on top of them, and for us it's critical to be able to deploy all the components on a node. And from the hardware perspective, or I don't know, from the, let's say, storage provider perspective, it can be anyone, right? So you can have multiple providers in the same cluster, like, I don't know, having like Trident or IBM or Dell storage in the same cluster, and still at the Porters level to work with the same functionalities, same storage class definitions. You can work with local drives, as I told you. If you are going for the cloud, we know how to work with Azure disks. We know how to work with EBC in AWS. So we are pretty flexible from that perspective. And from the application perspective, actually, right now, we are supporting all the applications which are cloud native. Let's say they have a deployment, or they have an architecture which is cloud native. And yeah, I forgot to mention, we also have, let's call it a solution, which is called PDS, Porters Data Services. Porters Data Services allows you to deploy a database without knowing anything about how to configure a database. We have right now 14 databases in our catalog. From Cassandra, Crouchbase, you can see all of them on the bottom of the screen. So actually, you just need to connect. This is like an automated tool which is running in the cloud. You can connect your cluster to this tool and just say, hey, I would like to run my Kafka cluster or my Elastic cluster, my Elastic database on this cluster, and I want to. You can do like T-shirt sizes, and you apply the template for that one, and PDS is automatically going to deploy the database, is going to configure it, is going to provide you, for example, a load balancer for external connections, credentials, everything. So, and by the way, we are also doing level 1 and level 2 support for those databases that we are supporting. So that's PDS, and that's actually what is our ecosystems of partners and how we are integrated with them. Yes, from the partners perspective, we have a couple of very good collaborations across, I would say worldwide, with a couple of, let's say, huge solution providers, which they also provide like cloud solution at some point. Now it depends. Usually customers which are looking for working with, for example, with the partner at some point, which is delivering solutions, I don't know, all across the globe, can get in touch and I don't know, work with one of them, or you can work directly, I don't know, with if you're already having a contract with Red Hat or SUSE, that's pretty much the same thing. Now, because just 2 slides I'm going to mention about it, it's the VM part. So as I mentioned, we have an initiative with SUSE and Red Hat about running the possibility of running VMs and containers together. So right now on OpenShift, we are able to run the VMware part, the KubeVirt part, and provide persistent storage for the KubeVirt. And more than that, we are able to provide availability for those VMs. So basically, you can do VM migration like you are doing in VMware. You can do you are going to be able to do storage vMotion at some point and storage DRS, which are on the roadmap. So again, functionalities like we have right now in VMware. So if you are thinking of at some point moving part of the workloads in VMware to let's say to another platform in order to offload the VMware cost, keep in mind that right now Red Hat and also SUSE, it's capable of delivering through OpenShift virtualization and SUSE Rancher Prime and Harvester the possibility to run the VMs and containers all together in the same cluster. And Portworx is the, I would say, the recommended storage provider for that one, because actually we know how to do the data access part. We are also supporting the DR, for example, for VMs. So basically, in the same way that you are doing DR for containers, you can do it also for VMs. And we are also developing a lot of features right now for this kind of, let's say, use case, which is requested more and more from the market. Thank you so much. I will stop because I promised to have some times if there are like any questions or any discussions, further discussions related to functionalities, use cases, I don't know, any information that you would like to know related to Portworx or to the use case that was presented at the beginning of the meeting, of course.
No one in the audience has any questions, maybe I can start it off, Christian. I was thinking, I mean, we saw a lot of reference customers in the beginning of your presentation, and I shared our reference case from Sweden, but what would you say would be the parameters in terms of size or environment where it would make sense to start looking at a solution like Portworx?
I don't think it's about the size. I think it's about the need. So actually, for example, the minimum that we are required to deploy Portworx, it's a cluster of 3 nodes. A cluster of 3 nodes, it's almost nothing these days when you are talking about Kubernetes, really. So it's not about the size. Yesterday I had a call with an MSP provider, which is also a cloud provider for one of the countries which I'm covering. And actually it's a huge one. We are talking about a company inside France Telecom, and they are using right now 5 CSI drivers in their internal clusters. They start hitting some issues. So it's at some point, it's not about necessarily the size, it's about what you are going to hit from the performance perspective, data availability, automation, because what I'm seeing actually, usually customers, when they are moving to Kubernetes or they are moving persistent data to Kubernetes environment, they try to, they try to do it with the minimum functionalities and minimum resources. The more data and the more criticality of the data you have in the environment, you are going to realize at some point that you will need to go to the next level and try to have a solution which is mature and capable of delivering all of those functionalities. And it's not only about the technical perspective, it's also about the business perspective, because if you are moving a critical database in the Kubernetes environment and the business owner comes and say, hey, what happens if we are losing the data center tomorrow? What would be the RPO and the RTO? Because I don't know, for example, half an hour of outage, it's $500,000 for us. How fast can you provide a solution in order to have the services up and running? Or I don't know, we have ransomware attack. How you are going to, and by the way, ransomware in Kubernetes, it's happening. And how fast can you restore the data? How sure you are that the data that you are going to restore, it's viable, you know, so it can be used. At some point, it's also about who's consuming those resources, how you are doing the resource control, how you are doing the resource monitorization, and that's why I'm saying that it's about at some point of what are the problems that you are hitting in production. And it's also, of course, related to the business criticality, because if the business say that this service is critical for the company, then yeah, you will need to ensure that you can provide a certain level of SLA for that data.
Okay, thank you. So in case there are no other questions here, I guess we're ready to finish off. Thanks a lot, Christian.
Oh, thanks a lot for the invitation. Thanks a lot for the attendance.